Hello, my name is Jacob. I'm going to talk a little bit about the hardware and the sensors, and the hardware parts of the ClimaCheck system, and the panel, the logger, and the sensors, the temperature and pressure sensors that we use when using the ClimaCheck system. To make the ClimaCheck analysis, we need to collect some data. We need to measure some inputs, and the inputs we need are pressures, temperatures, and electrical power input. So we need to measure this. We're able to do for us to do the ClimaCheck analysis. Then the first three here, the pressure, temperature, and electrical power input, is the inputs that we have to have, but there are also, as we will see, other types of sensors that can be used, like humidity, for example, and other things that can be interesting to look at as well when doing a ClimaCheck analysis. But what we'll be focusing on here is the pressure, temperature, and electrical power meter. The ClimaCheck system is divided into two parts, you could say. We have the ClimaCheck on-site, which is the portable version, more focused on shorter measurements. You go out to site, make a short measurement from a couple of hours to maybe a couple of days, and then you can pack everything and head on to the next site. And then we have the ClimaCheck online, which is then the version of ClimaCheck that is intended for continuous monitoring. So you install it on your chiller or heat pump, or you install it on your system, and you have continuous monitoring using the ClimaCheck online, the cloud service. The components, the sensors, the temperature sensors, the pressure transducers are the same. The measuring points are of course also the same, so there are quite a lot of similarities between these two, but it's the packaging that's differ between them. We will be focusing today mostly on the ClimaCheck on-site system and the different parts in that. So the standard kit with the ClimaCheck on-site system, the portable, is of course the central units, the gateway, which can be seen here. It's the black part here with the display that's in the panel. That's the whole case that comes with the system. And what's also included are of course temperature sensors. There are 8 temperature sensors in the standard kit. You can see one example here. And then you have pressure transducers with different ranges, and we will look into those as well today. But in the standard kit there are 2 pressure transducers included, a 35 bar pressure transducer and a 10 bar pressure transducer. Then there is one power meter included. That's called the EP Scout. It's this blue power meter you can see here, where you connect voltage and current. You measure voltage and current to get the power input to your compressors. Of course, then there's in the standard kit there are also current clamps or current transformers included. These can be seen here. You have a white model here, which is a smaller one, from up to 150 amps, and then you have the blue, which is called a Rogowski coil, which is another type of current transformer, and that can take up to 2000 amps. So when you get the ClimaCheck system, on the power meter, you will have either of these current transformers as well. And you can, of course, you can have both of the current transformers and switch between them depending on what you're measuring as well. Then you have a number of accessories, so you can add analog input modules, which are called R560s. That's the analog input module we use. That gives you more temperature and pressure inputs, so you can have more pressure and temperature sensors. And you can of course also add additional power meters, more of these EP scouts, so you can measure maybe 2 circuit systems or more systems or chillers at the same time. We will go through these different sensors and meters in the coming slides here. A quick note first about sensors and signal types. This is good to know what type of signals that are used in the ClimaCheck systems if you ever need to do some troubleshooting. That's good to know what type of signals that are used. And you can say that for analog signals, the most common, basically industry standard today, are 0 to 10 volt and 4 to 20 milliamp signals. The ClimaCheck default standard pressure transducers are using 0 to 10 volts, but we also have transducers that use 4 to 20 milliamps. The analog inputs can handle both, but the default settings for them and the default setup will be 0 to 10 volts. We get back to why this is good to know later on. For the temperature sensors, we are using PT1000 sensors. These are high accuracy temperature sensors with varying resistance. So depending on the temperature, the resistance varies in the sensors, and then that can be measured and you know what temperature you have. For the digital communication, so for communication between the power meter and the main unit, we use Modbus. We use Modbus RTU, which is a serial protocol, and that is then taking all the data from the power meters and from the R560, and it reads with Modbus to the main unit. So that's the way we get all the values, all the signals from the different sensors. If we then go into the pressure transducers, as I mentioned, there are different ranges. So the two standard, so to say, pressure transducers that's included in the standard kit are a 10 and a 35. This can of course be changed, and you can also add. So as you see, we have 5 different pressure transducers with different ranges. So we have up to 5 bar, 10, 35, 50, and 150. So typically for the 5 bar transducer would be used for low pressure refrigerants. If you go to maybe 410A, you can switch. You maybe need to switch to a 50 bar transducers, and if you're measuring on CO2 systems, you may need to go to the 150 bar sensor. But all the inputs on the logger can be changed, or can be changed so that they can use any of these pressure transducers. But as I mentioned, the standard kit comes with this 10 bar and 35 bar pressure transducer. You connect the pressure transducer cable to the pressure transducer, and then you have a DIN connection that you connect in the panel, which you can see on the right here. This one. And on the panel you have 4 of these analog inputs with DIN connector. So you can have directly on the panel, you can connect up to 4 different pressures. And then, as I mentioned, you can add additional R560 modules where you can connect more pressures. But the connection also looks the same with this DIN5D connector for the on-site version. The pressure transducers have, when you connect them to your system, they have a 1/4-inch flare connector. Make sure that you can connect this to your system, so you have a 1/4-inch flare connections that you can use. Some systems, especially like 410A, may have a different port, and CO2 or high pressure refrigerants or ammonia may also have different types of ports, so then you might need something in between, so you make sure you have the right equipment when you go to the site. Also, as I mentioned, the analog inputs on the system, they are configured for these different ranges. So when you connect, make sure you follow the instructions. So, for example, we would usually use analog input 1 for high pressure. If it's a simple system with only high and low pressure, we will usually use analog input 1 for high pressure. Analog input 1, the default configuration for that is a high pressure 35 bar sensors. If you're using something else, you need to change the configuration. We will get into that as well. But if you follow the instruction, connect, make sure you have the correct range. So for high pressure, the 35 bar, you connect that, you connect it to the analog input 1, you should be okay. Of course, and then the default setting for the low pressure would be to connect that to analog input number 2, so that would be configured for the 10 bar transducers. If you mix this up, so if you, for instance, connect a 35 bar sensor to the 10 bar input, your measurement will not be correct, your value that you will be reading will not be correct. We get into this later, how you can check this and how you change the configuration as well. But just make sure that you know what your inputs are configured for and that you connect the correct transducers to the correct point on your system. On some systems, there might be already factory installed pressure transducers that take up this server point, so you cannot connect, and then you might need to add a T-piece so you can have the factory installed sensors at the same time as the ClimaCheck pressure transducer. So then you might need to consider that when going to site, that you might need a T-piece as well to be able to measure the pressure. If we go into temperature sensors, as I mentioned, we are using P2000 sensors, and which is a high accuracy sensor. It has proven to be have good stability over time as well. And our sensor come in a 5 and a 10 meter lengths. Typically, the 5 meter will have a white cable, and the 10 meter will have this red cable that you can see on the right here in the picture. All of our temperature sensors have a 3.5 millimeter teleplug that connects to the panel, or then connects to the panel. On the panel itself, you have 8 inputs, so from TT1 to TT8, and you connect each sensor to these inputs. As I mentioned in the beginning, the P2000 sensor works in a way that it has varying resistance for different temperatures, so that makes it also very easy to check. If you ever have a problem with the sensors, you can just measure the resistance over it, and you can make sure if it's working or not. A note here is that you always try the best you can to keep these connectors clean, so you don't get dirt and debris in them, because then you might get errors in your readings. But contact spray or something like that would usually clean them up if you ever have problems with them. We also have another type of temperature sensors that can be used with the system. So on the panel, on the lower side, I will show a better picture in the coming slides here. You have something called one wire, where you can connect one wire sensors. These are different type of sensors. These are bus sensors, so they have a built-in chip and they communicate digitally with the panel, and then it communicates the temperature that way. It has has a lower accuracy than the P2000, and it also has a smaller range than the P2000, but it's a cost-effective sensor to use if you only need to add a couple of sensors. But the standard sensor we are using in the ClimaCheck system is the P2000 sensor. But the one wire is also a possibility. Sensor installation, and when you mount the sensors to the systems, make sure that you do it properly. So make sure that you have a good connection with the pipe that you are mounting the sensor on. Remember, the temperature that we are trying to measure is the refrigerant or the water or air inside the pipe. So we need to have a good connection to the pipe. You don't want any good connection to the pipe. You need to use this heat transfer paste. You need to add aluminum tape to get a good heat transfer, and always ensure that you have a good contact between the sensor and the tubing. Our P2000 sensors looks like this, the top picture here, and they have a small groove in them, so they get a good contact to a round tube. And these are preferred to compared to normal sensors that usually looks like this, the lower picture here where you have a round sensor body. So this is better when measuring on outside tubes to get a good contact with the tube. We also have a sensor type called the test plugs or insertion binder probes that you can use for the secondary side, the water or the glycol side, where you mount these on or have them mounted on the system, and then they have a membrane, and you push this along sensor through this membrane, and then that means you can measure the inside the tube on the water or glycol solution on the secondary side. So these are for the secondary side, these are not for the refrigerant side. For the refrigerant side, we use this surface mounted P2000 sensors. So I said you needed to have heat transfer paste between the sensors and the tube. You need to add aluminum tape, and then you need to insulate around the sensor and the tube to get a good reading. And how much should you insulate? Well, these are some rules of thumbs, but you can say that on smaller sized tubes made of copper, which has a good heat transfer, you need less insulation, but on bigger tubes you need more, and with other materials like steel or plastic or stainless, you need even more insulation to get a good heat transfer and to get a good reading from the sensor. But these are some rules of thumb that you can use. Of course, if there are also some other considerations here, where if you're measuring on the suction line, for example, and you get risk of condensation on that low temperature, you need to insulate more, because you don't want condensation or water on the sensor. That will mess up the reading or affect the reading. Anytime you have a big temperature difference, so delta T, temperature difference to the ambient, again the suction line or the discharge line will probably need more insulation than maybe the liquid line, which may be close to the ambient. So for electrical, for the power meter, As I mentioned, we need to measure active electrical power input to the compressors. And on many systems today, there are already current measurements, but the current measurement alone is not enough. We need both the current and the voltage to get the power input. We use this Power Scout power meter, where you connect current transformers and voltage probes to measure the voltage. Anytime you're dealing with a power meter, make sure that you first connect the current transformers and basically all the cables to the power meter itself before you connect it to the voltage or the current cable where you're measuring the current on the cable. So connect the current clamps and the cables to the power meter first, and then you connect it to your system. There are two types of current transformers for this meter. We have the smaller white one to the left here, which has a range between a half or 1 amp up to 150 amps. And then we have the larger blue Rogowski coil that can handle, has a range between 20 and up to actually 4,000 amps. The power meter, if you can have, you can order either or you can also have both of these current clamps, so you can change depending on what you're measuring on. But if you change from one current transformer to another, you need to change the configuration in the power meter. The power meter is configured depending on what current transformers you connect to it. This is described in detail in the manual. We will show you later on in this presentation as well where you change that. We need to connect, we need to measure voltage. With the ClimaCheck system, this is measured with probes for the portable, or if you're doing a fixed install, there will be screw terminals where you connect the wires. These probes can either, we will show, they can either be probes or there are also a version with magnetic ends on the cables. I will show you this in the coming slides here. The current measured with the current transformers. As we have seen, we have these different ranges of current transformers. You should pick, or you should use the one closest, which match closest to what your load is. So do not measure a 10 amp load with the Rogowski coil, or do not try to measure a 170 amp load with the 150 amp white current transformer. The output from these current transformers are millivolt signals. For the fixed installed ClimaCheck systems, there are also versions with current transformers that have a current output, a current signal. But for the portable, there is a voltage signals, which is a signal between 0 and 333 millivolts. Anytime you're connecting to a system that has an inverter in it, or a variable speed drive, you need to measure the current before. So you need to measure on the input to this inverter or variable speed drive. If you measure the current with the standard current transformer after, the measurement will not be correct. So make sure you measure before inverters. When connecting the voltage, as I mentioned, we have these red and black probes that you connect to like a screw or where you can get a good connection. And we have these cables as well, which has a magnetic end here, so they will attached to a screw in the installation, and you can hook them up like this, as you can see in the picture to the right here. Anytime you connect the power meter, make sure you're focusing so you get the L1, the phase 1 input to L1, phase 2 to L2, phase 3 to L3. So you're making sure that you check the labeling in the system you're connecting, so you get these phases correct. If these are switched or mixed up, you risk ending up with errors in your readings, in your results. So make sure you're focusing on that you connect L1 to L1, L2 to L2, and L3 to L3. And as I mentioned before you start connecting in your system, connect the cable to the power meter at first. I should mention also that the power meter, it can be powered through a USB cable, but when you're measuring, it will also be powered over L1 and L2 inputs. So when you connect voltage to L1 and L2 inputs, the power meter will start up. So in that case, you don't need the USB cable. Then when we connected the voltage, we need to measure the current as well. Again, first connect the connectors or the cables to the power meter like this, and then you connect the current transformers around the cables in your system. Again, make sure you're checking that you're connecting L1 to L1, L2 to L2, and L3 to L3. All current transformers also have an orientation, and they have a specific way that they need to be installed and that the current should flow through them when you're measuring. This is indicated in different ways on these different current transformers. On the white, smaller current transformer, you have a label. It says this side towards source. So in that case, if you check on the picture to the right there, the current comes in from the top, from the source is up here, and it goes through. You see the label is pointing up. It says this side towards the source, which is up, and the current is going from up and down through them. That's the correct way to install them. That's the way the current should flow through that type of sensor or current transformer. The blue Rogowski coil has an arrow on them. So on top here, there is this arrow you can see, and of course the current should flow in the direction of this arrow. So this arrow should point at the compressor. So this is important that this orientation is correct when you connect the current transformers. There are some, if you happen to mix this up or you don't get the connection correct, you have a first indication in the power meter itself, and it's called phase check. So you have a green and red LED above the connections for the current clamps. So if your compressor is running and you see that you have a red indication, most probably you need to go back and check your connection, but you probably have mixed up the phases or put current transformers in the wrong orientation or something. So then you need to go back and check your connections again. This indication, this phase check, is actually checking the power factor on each phase. And this value is also available, so you can actually check that as well in your measurement, the actual power factor value. We'll get back to that a little bit later, but this is the first indication. When you connect the power meter, do check these LED lights on them. They should be all green when the compressor is running. the panel. The whole panel then looks like this. We talked about bits and pieces of this. You can see here that you have the 3.5 millimeter teleplug connections for the temperature sensors, the TT1, 2, 3, 4, 5, all 8 inputs, like this, where you connect the temperature sensors. On the side here, you have the analog inputs for the pressure transducers that we talked about. So we have analog input 1, 2, 3, and 4 here. This is where you connect the pressure transducers. Again, these analog inputs are configured for different transducers. The default setting is 35 bar sensor for analog input 1, 10 bar sensor for analog input 2, and then 35 and 10 again for analog input 3 and 4. This can then, as I said, be changed. So if you're using a 50 bar sensor or 150 bar sensor, you can change the configuration on each of these inputs. I will show you in a coming slide where do you do that. The other connector here, where you can see a power meter, is the Modbus connection. This is the RS485 or Modbus connection for external units. So for your power meters, or if you have additional R560s, these are all connected to this connector, and that's on the right side here. That is labeled RS485. And the way you do this, if you have this is only one connector, but you on each of the external units there are always two connectors. So you connect the first one to the panel. Let's say you have the first power meter, you connect that to the panel here, and then on that power meter you connect, or to that power meter you connect the second power meter. So there, and then if you have additional R560s, you connect them as well. So you have a long Modbus connection, or Modbus cable with all of these connected. On the left side, you have the USB connector. This is used then when you're reading the data to the PC software. So you read all the data out from the logger into the PC. You can connect this USB cable on the left side. There is also an Ethernet connection for internet. If you're connecting to ClimaCheck Online, you can use that, or for updates of the firmware in the unit. On the lower left side here, you have a fuse, and then you have the 24-volt power that you connect to it for it to start up. Anytime if you need to restart it, there's no on and off switch. You just pull the 24-volt power input and then you reconnect it to start it up again. The gateway has a built-in battery, so it will have a controlled shutdown and start up each time, even when you pull the voltage from it. On the lower side here, you have the connectors for the one-wire sensors, and there are also a connection for some digital inputs that can be used in the gateway. As I mentioned here, the default way then is to read the data with the USB cable, but the system is also capable of using Wi-Fi or Ethernet between the computer and the main unit to read data. So you can use the ClimaCheck software in your PC when doing a measurement, and you can then read the data from the logger to the software over USB, which is the default. And also over Wi-Fi connection or Ethernet cable. And when you start the system up, if you look in the display, after a little while you will get a question. It will say connect to PC, yes or no. Of course, if you're measuring with the PC software, you should choose yes here. The default setting is that it will go to yes anyway. So if you miss it, it's okay. It will continue. It will assume that you want to measure with the PC software. Then it will ask you which connection type you would like. If you don't choose anything here, it will default to activate the USB cable and also the Wi-Fi access point in the gateway. So then you can either connect, if you don't do anything, if you start it up, you will end up with USB and Wi-Fi activated, and then you can connect either the USB cable or you connect over Wi-Fi to the access point that the gateway has created. If you want to use Ethernet cable, you need to actively choose direct, it says direct Ethernet cable when you get the question of connection type. After the startup, you can also look at the bottom of the display. You will see that for in this mode, it will say PC mode here at the bottom, and it will say USB and Wi-Fi. So then you can see after it has started up, you can see what mode it is in. And also in the same way for Ethernet cable, if you choose an direct or Ethernet cable here, it will say PC mode Ethernet cable. So then you know which mode is activated. But if you're not actively choosing anything, you will end up with the PC connection activated, and it will be through the USB cable or Wi-Fi. That's the default setting. You have some LEDs on the main unit itself. They are called AB, S1 and S2, and on the side of the panel you can also see that there is an explanation what they mean. So you have an LED for ClimaCheck Online, one wire Modbus, LED status, and a modem. If you're using the system in the on-site version, you're doing with the portable system, the on-site, and you have the PC mode activated, the default setting. The CC Online, of course, you're not using that, so that will be switched off. The first one, A here, will be switched off. The second one, that's called one-wire Modbus, is an indication of the communication of the Modbus units and the one-wire temperature sensor. So let's say you have your one or two power meters configured in your system, connected or configured. The main unit will try to communicate with this, but if it doesn't succeed, if it doesn't, okay, I don't have a connection to the power meter, this will B LED will start flashing red, telling you that, okay, something is wrong with the one-wire Modbus communication. And of course, then you will not get any values from that parameter, so then you need to check the Modbus cable between the panel and the parameter or external R560. So this is a communication indication for the Modbus and one wire. You have a status LED, which is more for the system itself, the built-in system. Should be green when using it online, but you can also check when you connect the USB cable, it would turn more orange. So you can see if you connect the USB cable, you can have a first, you can just check that LED, and then you know, okay, the system has felt that you have connected the USB cable. The unit has a built-in modem that can be used to send the data to ClimaCheck Online, if that is used. on-site use, and with the modem off, the LED will also be switched off. In the display, there are then some other indications. So if you're using the modem, you will have a GPRS or signal strength indication to the far left here, where you can see how good your signal strength for the modem is. Same thing for Wi-Fi, you have a signal strength indication. And if you're connecting it to a LAN, you get this symbol as well for that when it senses that it has a cable, an Ethernet cable connected. And then, so these are mostly focused on when your system, when you have using the system with ClimaCheck Online and have it connected to the cloud. The last gateway here is indication that the system has connected to the ClimaCheck server and has a working connection with the ClimaCheck server. So most of these are, as I mentioned, focused on when you're connecting the system to ClimaCheck Online. But for if you're only using it for on-site, check these LEDs when connecting to make sure that your power meters are connected. And also an indication then that the USB cable is properly connected. If you get an error message from the Modbus, in the display it will also tell you that, okay, communication error, and it will tell you which unit, so maybe communication error power meter 1 or R560 unit 22 or so. So then you will get some more information if you look in the display. The display then, it has this quite big menu system where you can look at different things. There are also some you can also do some configuration from this menu. So you have this is touch sensitive display. So in the display you have buttons on the lower side here and on the right side, and you can then enter the main menu by pressing the escape, and then this picture is also in the manual, of course. So then you can go through the different pages, and you can look directly on the values from the sensors and the meters directly in the display if you like. You can start or stop logging to a USB memory, and you can save or restore configuration from a USB as well. That type of thing can be done from the menu directly in the display of the unit. As I mentioned earlier, when it comes to configuration, this is a configuration that cannot be done in the display. Configuring pressure transducers or adding additional hardware like R560s or more power meters, you need to use the PA-Pro-free configurator. This is found in the PC software. When going through the PC software, we will show you exactly where to find this, but it's on a menu in the PC software. You start something called the PA-Pro configuration. Looks like this. And then you get, it starts another window where you can load and change and read back the configuration of the gate or the main unit. And this is where you find all the configuration for the analog inputs, or if you're adding more external units, this is where you need to go. Of course, this is also described in the manual step by step if you need to change for example, the pressure transducer. This is described step by step. But the program looks like this. It has different tabs up here. We will now just focus on the first one that's called IO config edit. So this here we can load and change and read back the configuration of the analog inputs, temperature inputs, and you can change all the configuration for all the inputs on the system. When you have connected, you need to go to action and the action menu here and connect to the system, you will get an indication down here that says, okay, I'm connected, and it will show you the ID of the system you're connected to. And then from this edit device menu here, you can read back or read the current configuration that you have, and it will show you the configuration like this, where each of these lines or each of these rows here are different hardware. So in this case, you can see you have 3 rows. They call devices here, device 1, 2, and 3, where the first device, or the unit itself, it has 4 analog inputs. So you have configuration of that from the first row. The second row is one of these R560 modules that has 8 analog inputs. And the third row is the power scout and the power meter. So in this system, you have 3 different units. You have the main unit, you have an R560 for the temperatures, and you have the power meter. These are the 3 units that are configured. Of course, if you then have more power meters or more R560 analog modules, you will get more rows, and you will then see that the device index continues here, like 4, 5, 6, 7. Okay, so let's say then we want to change our analog input. We need to change that to use a different pressure transducer. Then you press the plus sign on the left here, and that will open up that unit. You can see that we have now opened up the first row. This is the 4 analog inputs for pressure. These are the 4 analog inputs that you have on the panel, analog input 1, 2, 3, and 4. So you get 4 rows like this for each of the input. And then on this drop-down menu, you select what type of sensor you want to connect to this input. So the default setting, as I described before, is that analog input 1 is configured for a 35 bar pressure transducer. Let's say we want to use a 50 bar instead. What we do then is we go in here, we go to analog input 1, in this drop-down menu, we select the 50 bar instead. So you can see here you have 10, 35, 50, you have all the pressure transducers. You can just select which one you want to use. You press, you select, let's say, the 50 bar, and then you go back to this edit device and you write the configuration back into the logger, and then the logger will read. We want to reboot, and then you can start measuring. You can use the 50 bar for the analog input 1 instead of the 35. So this is the way, if you change between different pressure transducers, this is the way you do it. You use this ClimaCheck configurator, you find the input that you want to change, and of course if you have external R560, as I will show you, you can have analog inputs on those as well, so then you can change the configuration, and then instead of these 4 lines or 4 rows, you will get 8 rows because you have 8 different inputs on the R560 module. And then you just select from the drop-down menu what type of sensor you want to connect, and you save the configuration. The R560 unit, when installed in the panel, you just see the front of it like this. And if you're adding another R560 module to get more inputs, each of these modules have 8 inputs. So when adding more, you get this. For the portable version, then the additional R560 looks like this. You still have 8 inputs on them, but for this portable version, you see that we have doubled up the connectors here. So for the this is for analog input 1. You have both a P2000 temperature, a 3.5 millimeter connector here. You have the DIN connector for the pressure. Same thing for analog input 2. You have 3.5 millimeter for temperature and analog input for the pressure. So these two are analog input 1. These two are analog input 2. You have analog input 3 and 4. They can only use temperature sensors. And then you have 5 and 6. It's the same story, and they can be, you can use both pressure and temperature. Of course, the module itself only has 8 inputs, so you cannot, for analog input 1 up here, you cannot use temperature sensor and the pressure transducer at the same time on that input. So you need to choose. So let's say you want to connect 2 pressures and 6 temperatures, then you will connect the pressures. You will configure the inputs, input 1 and input 2 here, as I showed in this configurator software. You will configure them for the pressure transducers you want to use. You connect them to this and this port, and the remaining 6, so the input 3, 4, 5, 6, 7 and 8, they are configured for temperature, and you can connect the temperatures to these inputs. So this way you can configure and you can alter what type of sensors you're using with this R560 module. But the total number of inputs are 8, so you cannot connect more than 8 sensors at the same time. We will quickly go through some common problems that we see when connecting. I mentioned some of them already with the power meter, but mention them here again. The most common problem we see in measurement, they are connected to power meter, the measurement of the power meter. There's only one way you can connect the power meter which is correct, but there are a number of ways that it can be wrong with if you switch between the phases, as we have talked about, or you put the current clamps the wrong direction and so on. Other common problems that we see are if you are using the wrong template or flow chart in the software. We'll go through this in the software part of the training. And then that you mix up temperature and pressure sensors. So let's say you connect the discharge and the suction line temperature sensors on the system, then you run the cables back to the panel, and on the way you mix them up. So then most of those things are easy to catch if you're actually looking at the input data when you start measuring, but it's an easy mistake to do. So make sure you connect all the cables to the correct inputs. But here we will be focusing mostly on the power meter, because that's where we see people have the most problems. When you start a measurement, anytime you start a measurement, check what readings you get when you connect the power meter. Start with the voltage. Make sure you get a voltage on all the 3 phases. It should typically show something around 430, 440 volts. The deviation between the phases should be small, normally less than 10%, so you should not have 230 on one and 110 on another. Then you probably don't have a proper connection. So check that your voltage are reasonable and that they do not deviate from each other more than 10%. And then if we go to current, the current values you're reading, check those as well. When you have connected the current clamps, check what readings you are getting. Again, normally the deviation between phases are small on the systems we're measuring on. Again, check that they are reasonable. So if you suspect, or if you know that, okay, this system should have around 50 amps of current, If you then are getting 10 or 250, probably something is not properly connected or properly configured. So just check the values you are getting when you connect the power meter. And if possible, compare the current you're getting with like nominal data. Maybe often you can see it in the control system of a chiller, or if you have a handheld current meter, you can just check the value with the second measurement with that. All of these values, you can see them in the display of the power meter, and we also read them back to the main unit, so you can see them online or in the PC software. We always read these back and log them, all this voltage, current, and also power factor. We also read, and the power factor is a very good value to look at to make sure your connection is correct. Most of these things that we have talked about, where you mix up the phases or you put the current transformers the wrong way, most of these things will be showing up on the power factor. The phase check that I talked about earlier also is based on the power factor. So always look at the power factor. At full load, you would normally see a power factor above 0.9. On low part load, it can go down to 0.6. So upon part load, you should probably see something around between 0.6 and 0.9. When measuring before an inverter, you should see a power factor close to 1. So if you have an incorrect connection of the power meter, what will happen is that you will get way off from these values. So it can show values, sometimes negative values and sometimes very low values like 0.0001 or something like that. So check the power factor. If it's something outside of this, so between 0.6 and basically 1, you need to check the connection. For the voltage, I mentioned to check the voltage. If you see that you have a problem, if you have the previous generation that is called the EP Pro, previous generation of the power meter or the ClimaCheck system, that has fuses on each phase on the voltage measurement. So if you don't get a reading, check those fuses. The EP Scout has fuses, but it's internal fuses, you don't change them. Basically they don't go out unless you do connecting something very wrong to the EP Scout. So that is usually not a problem. But if you don't get voltage and using the EP Scout, check the connection. Check that your cables are properly connected. Check if you're using the magnetic cables. Make sure they have a good connection and has not fallen off. So just go back and check all the connections again if you don't get a voltage reading. If you then look at current, if you see that you get a too high current, you're reading 100 amps, but your system should only be using 50 at this load. First of all, make sure that what you are measuring is the current only to the compressors. For the ClimaCheck analysis, we need the current only to the compressor to start with. So make sure that it's not included a fan or pump or anything like that. If you get strange or usually low values, if you see that you have too low values, check that the current transformers, the Rogowski coils and the current clamps, that they are fully closed. So they are not stuck on some cables. So just make sure they are fully closed, because otherwise they will not read the correct current. Also, if you get strange values, check, and you have both the Rogowski and the smaller white current clamp. Make sure your power meter is properly configured. As I mentioned, you need to change the configuration when changing between the white current clamp and the Rogowski coil. And also, if you're doing extension or have long wires between the power meter and the current clamp, make sure you don't have too long wires. Basically, our suggestion at any time, you should also always first try to move the whole power meter and not extend the cable between the power meter and the current transformer. So keep that with the original cable if you can, and then you take a longer Modbus cable. If you have a long distance between where you can measure the power and where you measure the pressure and temperature, use a long Modbus cable instead and move the whole power meter to where you can measure voltage and current. If you can avoid it, do avoid to extend and use long cables for the current clamps and all the voltage connection. And if you do need to extend them, there are guidelines in the manual how you should do this and what type of cable you should use. Again, the power factor, a little bit depending on the configuration and version. You may see that when there is a communication error, or the Modbus communication between the main unit and the power meter is not working, that will be indicated on the power factor value as -9 or -900. Of course, as we looked at before, this will then also be indicated on the LED on the panel. The Modbus LED will blink red, and of course you will not get any values at all if you don't have a proper Modbus connection. If you ever get this, first of all check that the power meter is on. Remember, it was powered when you connect voltage to the voltage inputs. So make sure it's on, first of all, and then check that your communication cable between the meter and the panel, the logger, is connected. The Modbus RS485 Modbus cable is connected. And then if you still don't get communication, you need to go in and check the Modbus address and the baud rate setting in the power meter. Each of these power meter has a different address on the Modbus address that is used. So if the logger is trying to read data from power meter with Modbus address 2, and you have another Modbus address configured in your meter, the communication will not work. But first of all, check that it's on and that the cable is functioning. As we already mentioned, when you're getting strange power factor values, then go in and check your connection of the current transformers or the clamps. As we shown, check the direction with the arrow or this label, this side towards source. So check that the orientation of the current transformer is correct. Then check that you have matched the different phases, L1 to L1, L2 to L2, so there is not a mismatch between voltage and current and the way you're measuring. So go back and make sure you are actually measuring on the phase you think you are. If there is a long way between the point where you can measure voltage and the point where you can measure current, it may be tricky to see that, okay, this is actually the same phase, but then you can measure, try to measure the voltage on the cable where you have your current transformers connected. So take your power multimeter, measure the voltage. This should be the same phase, so the voltage should be 0 volt. If you get a voltage between the point where you're measuring voltage and you're measuring current, it's not on the same phase. So that's a way to check that you're actually measuring on the phase you think you are. You should always try, last point, interference. You should always try to avoid running sensor cables between power lines. There will be interference from power lines, so try to always avoid that. For the Modbus, the interference will be shown up as intermittent connection, so it goes on and off, and you can't really understand why. Go and check that you do not have interference between power lines. One wire the same way. They're also sensitive for interference from power lines. And basically no sensor leads should be run alongside power lines when you measure. If you, another thing, if you get problems with power factor value, you have a strange power factor value, and you have used extensions on between the power meter and the current transformer, make sure that they are all the correct size and that they are not too long. We have more information on this in the troubleshooting guide and in the manuals, but basically if you're using the older traditional current transformers with a current output, a 5 amp current output, it's not recommended to do longer than 5 meter cables between the current transformers and the power meter. The Rogowski and the millivolt transformers are less sensitive. In theory, as you can see, they can handle up to 30 meters or actually up to 100 meters for the millivolt. But practically, as I said, we always recommend to try to use the standard length of the cables between the power meter and the current transformer, and then use a longer Modbus cable back to the panel or the main unit. Of course, all of these can have problems with interference from power lines, and the longer cable you have, the higher risk you get. Again, anytime you have an inverter in your system, a variable speed drive, you need to measure before this inverter, so you need to measure the current on the supply to that inverter. You will see that you typically have a power factor of around 1 when measuring before an inverter. Inverters have some losses, and so you can add that in the PC software. You can add this loss factor, and typically an inverter has between 3 and 6% loss, but it's very easy to look at the nameplate of the inverter, and it will be stated what type of losses it has, so you can enter that. Pressure transducers, as I mentioned, they have different ranges. We have the 5, the 10, 35, 50 and 150 bar transducer. The inputs need to match the transducers you have connected. We have also transducers with a current, a milliamp signal. So make sure your input is configured for the correct type of signal and the correct range for that pressure transducer that you're using. Otherwise, the reading will not be correct. If you have problems with the cable or the connection, what you will see in the results is that no signal. Basically, if you don't have a sensor, the cable is broken. If you don't get a signal input from a transducer, the result you will see is a negative value, and this will depend on what type of transducer the input is configured for, but it will be from -2 to and lower. So in any time basically you have a negative value, go and check the connection, because probably your sensor is not connected properly. If you have a problem with the cable and you get a short circuit, you get 12 or 24 volt into the signal input, what you will see, it will go to the end of the range of that input, and again this will depend on if you have your input configured for a 10, a 35 and a 50, but basically what you will see is twice the pressure that your input is configured for. So for a 10, if you have it configured for a 10 bar transducer, it will show 20. If it's configured for a 35, it will show 70, and so on. And of course it will then be a constant value. It will not change with the system you're measuring. So when you see these type of problems, you have a problem with the connection, or the problem with the connection or the cable. There is an easy way to just make a quick check of the pressure transducer. If you connect them to the system and start reading the data, but just have it don't connect it to the pressure port, just have it in the air, it will show atmospheric pressure. If you look in the display of the NX400 or the gateway, it will show 100 kPa. If you look in the software, it will show the gauge value, which is the 0 bar gauge. That means atmospheric pressure. That means you know that you have a signal from your transducer and that it's showing correct value, at least in ambient air. Yeah, the table below there, you can see the ranges for the transducers, but in the PE Pro, as we have shown, if you need to change the configuration, change the input when changing between different transducers, you use this PE Pro configurator, and you have the drop-down menu where you choose which type of sensor you have. For the temperature, the P2000 sensors, again, if you have a problem with the cable, the values you will see, if you don't get a signal, your sensor is not connected or your cable is cut off, what you will see is somewhere around 150, so somewhere between 149 and 156 degrees, which is the one end of the scale of that input. If you have the previous generation RTDs, for the previous generation of hardware, you will get a 3,300 something value when you don't have a sensor connected. So watch out for these around 150 degrees values, and that probably means you don't have a sensor connected. If you get the short circuit on the temperature sensor, you will end up with negative temperature, and it will be -56 for the PE Pro and the R560 that we use today. So look out for these 150 plus and -56 degrees. That means you have a problem with the sensor or the cable. If you extend the temperature sensors, you need to adjust the offset. The P2000, as I mentioned, has varying resistance with varying temperature. The cable between the panel and the actual sensor adds resistance. It adds resistance, but the standard sensors, this is all already configured. So the standard ClimaCheck sensor has an offset of 0.35 Kelvin. This is all configured in the logger, so if you're using the 5 or the 10, these have the same offset. You don't need to do anything, you can just use them as is. The logger has the offset configured already. If you add cable to, or cut or remove cable from the sensors, you need to add or remove offset. So if you add, you need to, or if you extend the cable, you need to add an offset, and the offset you need to add, you need to measure the resistance in the cable you have added, and then you need to add 0.27 Kelvin for each ohm of resistance in that extension cable. So just keep in mind that if you change the length of the cables, you need to change the offset. And as I mentioned before, anytime you want to check a P2000 sensor, you can do that with an ohm, just measuring the resistance over the sensor. And there is we have this troubleshooting guide where you have a table with different resistance over different temperatures. You can check that your sensor is correct just by using an ohm or multimeter. All right, this was the hardware part and the sensor and hardware part of the ClimaCheck system. Check out your system, look what type of sensors and things you have in your system, if you have additional R560s, what type of sensor, what type of transducers you have in your system, and start connecting them and try to measure with them. And then we'll have a Q&A at we will have a Q&A at a later time, and you can have ask all your questions, and we'll have straighten the questions out. So thank you, and